Have you ever wondered what happens when different objects get squashed? Let's dive into the fascinating world of squashing. Now, squashing is simply when we apply force to an object, changing its shape. It's like when you step on a juice box and it goes squish. But not all things squash the same way. We've got all sorts of objects in this world, right? Some are soft like a marshmallow, while others are hard like a rock. And then we've got those flexible things like a rubber band. Each of these are going to react differently when we try to squash them, and that's what makes it so interesting. So imagine squeezing a sponge, or pressing down on a piece of clay, or even trying to squash a diamond. What do you think will happen? You're about to find out. Now, are you ready to see some cool squashing experiments? First up, we have soft objects. Can you guess what will happen when we squash them? Let's embark on this fascinating journey where we explore the world of squishy, soft objects like a sponge or a piece of bread. You can probably guess that they're easy to squash, but have you ever wondered why that is? It all comes down to the materials they're made of. These objects are composed of flexible substances that allow them to change shape with ease. Imagine a sponge. When you press down on it, the air trapped in its tiny holes gets squeezed out, causing the sponge to compress or squash. But what happens when you stop applying pressure? The sponge springs back to its original form, filling those tiny holes with air again. The same goes for a piece of bread. When you squish it, the soft, airy structure collapses under pressure, but can bounce back when the pressure is released. So, we see that soft objects can change shape when squashed, but they regain their original shape when the pressure is removed. Next, we have hard objects. Do you think they will squash as easily as soft objects? Welcome to the world of hard objects. Unlike soft objects, squashing hard objects isn't quite as simple. Let's take a rock, for example. Try as you might, no amount of pushing or pulling will change its shape. Why? Because rocks are composed of tightly packed materials that won't budge easily. Now, think about a metal toy car. It's a bit different from a rock, isn't it? But even so, you'll find that squashing it isn't an easy task either. It might bend or dent if you apply enough force, but it won't squash like a sponge or a piece of bread. So, what makes these hard objects so resistant to squashing? Well, it all comes down to what they're made of. Hard objects are typically made up of rigid materials that resist change in shape. These materials are so strong and tightly packed together that they won't easily give way when pressure is applied. In the case of the rock, its hardness comes from the compact arrangement of minerals, each one locked in place by its neighbors. These minerals are so tightly bound together that they can withstand high amounts of pressure without changing shape. As for the metal toy car, it's made of a material that is designed to be strong and durable. Metals are composed of closely packed atoms that form a strong bond with each other. This bond is what makes metals rigid and resistant to change in shape. So, here's a fun fact for you. The ability of these materials to resist squashing is actually a property called rigidity. Rigidity is the measure of a material's resistance to deformation. The more rigid a material is, the less likely it is to squash when pressure is applied. So the next time you're playing with your toys or picking up rocks, remember this. Their ability to resist squashing isn't because they're stubborn, it's because of their rigid structure. Hard objects resist squashing because of their rigid structure. Isn't that interesting? Finally, we have flexible objects. How do you think they will react to squashing? Now, let's dive into the world of flexibility and explore how these objects behave under pressure. Imagine a rubber band in your mind. What happens when you squash it? It stretches, right? And when you let go, it snaps back into its original shape. This is because rubber bands are made of a material called elastomer. Elastomers are unique because they can be stretched and deformed but always return to their original shape when the force is removed. Now let's think about a piece of clay. If you've ever played with clay, you know it's very different from a rubber band. You can squash it, stretch it, roll it into a ball, or flatten it into a pancake. But unlike the rubber band, the clay keeps the shape you give it. Why does it behave this way? Clay is made of tiny particles that slide past each other when you apply force, allowing it to change shape. But once you stop applying force, the particles stick together, and the clay holds its new shape. So, in the case of both the rubber band and the clay, we are dealing with flexible objects. These objects can be squashed, stretched, and reshaped because they are made up of malleable materials that can change shape easily. And here's the exciting part. The ability of these objects to change their shape has a lot to do with the world around us. From the elastic band in your hair to the clay used to make bricks for buildings, these flexible objects play a crucial role in our everyday lives. Understanding how different materials respond to forces like squashing helps us know why things behave the way they do. It also inspires us to create new and improved materials for the future. Flexible objects are fun, aren't they? They change shape when squashed, and they can even take on new shapes. So the next time you see a rubber band or a piece of clay, remember they're not just simple objects. They're little pieces of science waiting to be discovered. Wow, we have learned a lot about squashing today. We started off by exploring the fascinating world of squashing soft objects, where we saw how squishy things like marshmallows and sponges change shape when we apply pressure. Then we moved on to hard objects, discovering that things like pebbles and toy cars don't squash easily, but they do have interesting reactions under force. Our journey didn't stop there. We then ventured into the realm of flexible objects, where we found that materials like rubber bands and Play-Doh can stretch, bend, and even snap when squashed. Each experiment has shown us that different objects respond in their own unique ways to squashing, all based on their material properties. Our squashing adventure has truly been an exciting journey, filled with fun and learning. Next time you see an object, think about how it might react to squashing. Remember, science is all around us.